we continue with a few more concepts. And one of the concepts is to deepen here the aspect of interoperability. We want to have interoperability between different flavors of workflows. And that applies already to Python. So you have seen in the few screenshots I have shown to you already different flavors. Maybe we can also speak about different generations of Python. So one can describe the interaction with a code, like just with a script job. We have a bit more advanced concept of template jobs. We have this functional approach, which I try to highlight as a way of getting workflows interoperable and reusable. Behind this are at the end also different generations of Python, as I mentioned, which still have their justification. So there's executor lib as a way, if you really are mainly doing Python programming and would like to stay as close as possible to the Python syntax, but would like to benefit from the workflow capabilities, in particular with respect to automation of the interaction with HPC resources, then that's maybe the way you want to go, executor lib. Many of the activities and the projects of Materiality were based on Python base. That's so to say the classical Python framework, and we will continue to support this in order to also give the projects a chance to continue to work with their solutions. However, Python base has perhaps the slight shortcoming that you need to have rather deep Python knowledge in order to really implement new things. And therefore, we have extended now to a function-based approach to make it fully interoperable to the latest versions of Python, which are then function-based and have this nice graphical user interface that even if you are not an expert in Python or just you have only your Python function for a specific task, you would like to straightforwardly incorporate this in your workflow. That's best done in these kind of function-based approaches. There are different flavors of Python, and we always get questions for this, but let me here emphasize one thing. We have invested into what we call Python workflow definition to have a clear exchange format between these different versions. So no matter what kind of framework is maybe better suited for you, maybe we have done something in Python based and would now like to use all the advantages of the graphic user interface, then take the Python workflow definition to make this exchange. And so we will also somehow promise and ensure that in the long term, everything which is consistent with this Python workflow definition, and I will explain in a couple of slides a bit more what this means, will also be executable in 10 years. So we ensure this kind of sustainability, no matter that perhaps the front end might change. Because we are all here living in a dynamic world and we don't want to stay with the solutions 10 years ago, but we would like to make sure that things which have been developed 10 years ago can still be reused. And that's guaranteed by the Python workflow definition. The Python workflow definition does not only allow you to exchange between different flavors of Python, but also between different workflow management software tools. Yeah. So we indicated that we are using, for instance, here Python in Material Digital, but we are well aware and definitely also support that there are other solutions available. AIDA is very established in the atomistic world. JobFlow is coming from the materials project. The US activities as a workflow management system is established there. And we have SimStack here as well as a very innovative solution. And so an exchange ability between these different formats is also done by the Python workflow definition. And what does it mean without having time to go in all technical details, but make this clear, we ensure that we have a well-defined environment for executing the workflows. And this is keyword Conda, again, a package management system which ensures the kind of consistency of different software tools you would like to combine. Then you need a Python module for describing your different workflow steps, unless these steps are in some node store available. And then you describe your workflow itself in a JSON format. That's how it would look like. Don't care about all the details. Let's see a very simplified workflow. You have two numbers, 1 and 2, and you would like to get the product of them, and then the sum, and then the square, and then you get a result. So different steps. So each step is represented by a Python function. And that is what we put into the Python module. And then the workflow itself consists basically of these nodes. This are these kind of different steps which you individually execute, and of edges which are connecting these different steps. Yeah. And then so you need to somehow list these nodes with their properties, what kind of in and output they have, and you need to explain what the node edge is doing, which target port is connected with what kind of source port. And that makes the different nodes to a workflow. Yeah. This works then in a way, and again, sorry for showing here a few lines of code. Don't try to understand this code now, just to indicate to set up this workflow in Python, for instance, in Python base. These are the different steps. Yeah, so you have the different sum, product, square. Here is different functions. And what you need to do at the end is to write your workflow, which you have generated in this way, into the JSON format. And there are parsers for this. And then the other way around, you can also start Python base and read in a workflow which comes from somewhere else by this import command. And then you can nicely draw your workflow and do something with it. So this exchanging between different formats does work in this way.